By the end of this lesson, you'll be able to find a point where two functions meet. You'll also be able to use the quadratic formula to solve quadratic equations. A quadratic equation is of the form as squared plus bs plus c equals 0, where a, b, and c are constants and s is a variable to be solved for. Solving for s, we use the formula s equals minus b plus or minus square root of b squared minus 4ac, all divided by 2. So the problem we have here, the question we have here, we have it written in the form as squared plus bs plus c equals 0. And we see that the value of a is 3, the value of b is minus 11, and the value of c is 6. And so solving the quadratic equation, we get s equals minus b. Now the b value is minus 11 plus or minus square root of b squared minus 4ac, 4 multiply the a value multiply the c value, all this divided by 2a, and this reduces to 11 plus or minus 7 divide 6. So we have two values for s. For the first s value, we are going to use the plus sign. 11 plus 7 gives 18. Now divide 6, giving you 3. s2 equals 11 minus 7 gives you 4. So we are getting 2 out of 3. So these are the two answers for the s in the quadratic equation. We have a next question. We have the quadratic equation written in the form as squared plus bs plus c equals 0. And so comparing these two equations, the value of a is 1, the value of b is minus 2, the value of c is minus 15. Now we make use of the quadratic equation to solve. We substitute the value for the b, the a, and the c. So we have minus b plus or minus square root of b squared minus 4ac. Now all this divided by 2a. This reduces to 2 plus or minus 8 divided by 2. So the first s value, make use of the plus sign. 2 plus 8 divide 2, giving you 5. The second s value, we make use of the minus sign. 2 minus 8 giving you . So these are the two answers to the question. S equals 5, s equals minus 3 divided 2. The point where two functions meet. To find a point where two functions meet, we solve the two functions simultaneously. Now an illustration here. We see that the straight line intersects the curve at two different points. Maybe A and then second point B. How do we find this two points of interaction, we solve simultaneously. Let's have an example here. Question says that a curve 3x squared plus sy minus y squared plus 4y minus 3 equals 0 intersect a line. So let's name this one equation 1, and we have a line 2y plus 4s equals 4. And simultaneously, we make one of the variables in the second equation the subject. So I divide each term of this equation by 2 so that we make y the subject. Let's name this one equation 2. Now that one of the variables is made the subject, we solve simultaneously by substituting equation 2 into equation 1. So wherever we see y in equation 2, we substitute 2 minus 2s. So this first equation 1 becomes 3s squared plus sy. Now the y is 2 minus 2s minus y squared. Y is squared plus 4 multiply y minus 3 equals 0. Now let's expand this. We get 3s squared 2s minus 2s squared. Expanding this bracket, we get 4 minus 8s plus 4s squared. 8 minus 8s minus 3 equals 0. Now let's simplify. 3s squared minus 2s squared gives us s squared. 2s minus 8s gives us minus 6s. 8 minus 3 giving us plus 5. Now we are left with the bracket to expand. The negative sign here multiplying everything in the bracket, we get minus 4 plus 8s minus 4s squared equals 0. Simplifying further, s squared minus 4s squared gives us minus 3s squared. Minus 6s plus 8s gives us plus 2s. 5 minus 4 gives us plus 1, now equals 0. Have this quadratic equation to solve. Minus 3s squared plus 2s plus 1 minus 3s squared plus 2s plus 1 equals 0 is a quadratic equation to be solved. It is written in a form a squared plus bs plus c equals 0. And so the value for a is minus 3, the value for b is 2, the value for c is 1. Making use of the quadratic formula, s equals minus b plus or minus square root of b squared minus 4ac all divided 2a. And this reduces to s equals 1. Second s value is 1 out of 3. Now we are finding the point where the two functions meet. What we have done is to solve for s1 and s2. The next thing we want to do is to find the y coordinates of those points. how do we find the y coordinate of those points? We substitute the s values gotten into one of the equations given in the question. So I'm going to make use of the equation 2. The equation 2 is the same as the one here in the question. So making use of equation 2, y equals 2 minus 2s. Y equals 2 minus 2s is what we had as equation 2. So when s1 is 1, we will have y1 as 2 minus 2s. Now we are substituting the s value 1 through 0. When s2 is 1 out of 3, y2 is going to be 2 minus 2 multiply there. Now the s value 1 out of 3. This was 4 out of 3. Tells us that the first point where the two functions intersect is 1, 0. And the other point where the two functions intersect is 1 out of 3, 1 out of 3, comma, the y value 4 out of 3. We are done finding the two coordinates A and B where the two functions meet.